Okay, we're up and running. So this is AP mock exam 2012. So Julia and Caleb, I hope you're flying through the air and/or singing, and you can study this at a later date between now and Monday at midnight. Um, So number 8 in the this is multiple choice, no calculator. Calculator, no. Okay, so the first section, multiple choice. It's an oil tank one, and time is in hours, and R of T. So what is R of T? Oil being pumped into the tank. So this is a rate of change problem. Pumped into. So it's going inside the tank at a rate. So riddle me this, folks. If you say a rate of change and it says a Riemann sum, well, we can figure that out. And then at 15. And it was a little bit tricky. Most of the Riemann sums that we've done had a constant width of the rectangle, right? We would do like 3 and 10, and we'd get the area equals 30. Well, in this one, it's a little bit different because notice the difference here between 4 and 7 is 3. And between 12 and 15 is 3. So they're all 3, right? No. Between 7 and 12 is 5 units, and that's key to this problem, and I think a place where probably a lot of people would go wrong. So this one then was 3, and then it's a right-hand sum. Right-hand sum, which means you're going to take this first one, you're going to use the 3, no, go green, the 3 and the 6.2 for a right-hand sum. So this first rectangle will be 6.2, will be its height, and then the next one, we go down a little bit, its height is 5.9. So this is 5.9. And then the last one is even lower. It seems like that pump is starting to poop out. That's 5.6. This is a width of 3. This is a width of 5. Okay, so there's our right-hand sum. Question so far? So then we have the other thing to consider is the initial condition. Because it said oil is being pumped into the tank at a rate, R of T, where R of T is measured in liters per hour. R of T, liters per hour. T is measured in hours. Select values of R of T are given in the table. Using a Riemann sum, what is the approximation of the number of liters? So here's the big thing, folks. They don't want to know the rate of change. They want to know liters, right? So let's look at our units and let our units kind of help us. 3 is in what units down here? These are hours. And 6.2 is in what units? Okay, this is important, folks. Even if you're not paying attention this late on a Friday afternoon. Cade? Sorry? Yeah. It is really cool, and thank you for saying that. Okay, so now let's think about this. If I go hours, in this case, we'll do a specific example. If I go hours times 6.2 liters per hour, the area. Now I'm going width times height of this rectangle in my Riemann sum. The area of that sucker is in what units? And they do. This is the one case where you can use cancel. The hours cancel. Yes, doesn't it feel good? Okay. And we're left with the area of the rectangle in liters. And yeah, that's an integral. It really is. So we're left to the liters, and we're trying to get liters. What a happy day. So then the initial condition is important because we're trying to get liters, and the initial condition said somewhere a tank contains 50 liters of oil at time t equals 4, which was at the beginning. I need another color. Okay, so I can go initial right here, t equals 4. That's supposed to be an arrow. Man, my drawing sucked today. I apologize. But the initial condition is 50 liters. So then all we got to do to find the total number of liters, which is what they're saying, is find these three areas, which is a Riemann sum. And a lot of you articulated really well that you need to review Riemann sums. We were good at it before. So we would say that this is really an integral in disguise, that we're going from 0 to, what was it, to 15, 4 to 15, right, 4 to 15. I was going, wait a minute, that's not, so 4 to 15. Oh, and there we're good. So 3 plus 5 is 8, plus 3 is 11. We're at 11 hours. We're good. Okay, we're going to integral of from 4 to 15 of r of t dt. Really is what we're doing, but we don't need all that because it's approximately, it'd be 50 plus that. It'd be approximately 50, the initial condition in liters, plus whatever our Riemann sum is. Okay? That's not so bad. So that's 50 plus, well, we can go 3 times 6.2 plus 5 times 5.9 plus 3 times 5.6. 3 times 6.2 más 5 por 5.9 más 3 por 5 blah, 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 equal. And I think when you're done there, you get 114.9, which is C. And those are liters, not meters. Questions? Yeah. And that's huge. Oh, totally. And that answer's in there, A. Totally mean. But they do that. Yeah. Right. The big key here, and I love this problem, is if you use dimensional analysis, saying, okay, hours times liters per hour is liters, that really informs how to proceed. Questions? Gracie? You got it right the first time, so you don't have to worry about it. I don't believe you. But I thought that you all chose a good problem. You chose wisely. Number 9. Number 9. Yeah, and you feel guilty for it. Oh man, no self-respect there. Oh, that's funny. All right, so number 9, 2x plus 1. Hey, I have some of those cuties in the drawer if you want to not eat that vile candy. Yeah, so in that drawer behind Ms. Boatwright, because Cade left them here. Yeah, bring those out so they have a healthy choice. Yeah. Okay, so number 9 is 2x plus 1 times the quantity x minus 2 and x divided by x minus 2. So this is a great, and it says 4x not equal to 2, and this says 4x equal to 2. Now, let's kind of go way back a little bit. If I have these, there was a theme. You all asked for help on a couple of these problems that were of this nature. If I have good old XY coordinate plane, and it doesn't matter, let's say y equals 5, what does that look like? Y equals 5, what will that look like? Vertical? Yeah, you do. A horizontal line, correct. Okay, so if we say y equals 5, then that is a horizontal line where every point on here, this is the set of coordinates, and everywhere on here, that set is some x value, comma, 5. Some x value, comma, 5. Some x value, comma, 5. Correct? Right. Okay. No worries. If we say y equals 5, you're happy and it's easy and you go no problem. But then if we say, you know, for what value of y does something happen, then you freak out, because this one I didn't write this well. This was a k down here. And k just means for some value of y, and they want you to find that value. That's all that's happening. Okay? Let's think about this. And again, this is the no calculator section. Let's think about this graphically. First of all, forget about these limitations here. What kind of a function is this right here on top? The quantity 2x plus 1 times quantity x minus 2 divided by x minus 2. Now, initially you'd say a quadratic, and you would be wrong. It is a linear, and it's one of those sneaky linears, because the numerator up here, let's just say g of x equals this. The numerator is a quadratic divided by a linear, or in other words, a second degree polynomial on the numerator and a first degree polynomial in the denominator, and that equals a first degree or a linear. So that is a line, even though it doesn't look like it, but it's a line with one special feature that sets it apart from all its linear friends. Exactly, Calvin. You made up for that last, comment you made. Okay. Yeah, that thing is a line, and it has a y-intercept at 1, I believe. Tell me if I'm wrong. A y-intercept of 1 and a slope of 2, yeah? So it's really y equals 2x plus 1. What happened? These guys divide and become 1. These guys divide and become 1, but don't lose a root here is the only warning I will give you. This is just y equals 2x plus 1 It's just a line, but as Calvin said, it has that one special characteristic up here at, what would it be, 5? It won't let me do that. That is so upsetting and disappointing. Up here at 5 and at 2, there's a hole. So this particular function is continuous for all x except where x equals 2. It's not defined. You believe me, Lupita? ¿Está bien? Okay. So that's why we're saying right here for x, x can't be equal to 2 because it's undefined right here. If you graph that on your calculator and you go to table and you look at x equals 2, it'll say error on your calculator, but really it should say undefined. So then the big question on this problem was where, or what can we do to this function to make it defined for all x, including 2? What can we do to it? We just got to fill in the hole. Okay? Right. And how do we fill in the hole? Let's do some other function, some cheap, easy function that'll just blast right through this hole. How about y equals 5? It shouldn't be legal, Cade. It should not be legal. It's too easy, but let's do it anyway. Right? So let's do another function, and that function is y equals 5. And then when you put these two together, you get, okay, now we can say f of x equals y equals the whole thing, whatever we had up there, except where x equals 2. And then we can say y equals 5 at x equals 2. I can't even remember what we had. 2x plus 1. I knew that. 2x plus 1 times x minus 2 over x minus 2. Okay. And in this case, we would say, all right, what value of k makes that work? And we just say k equals 5. And that should have been one of your choices in the multiple choice. What was it? E? Okay. Does that help? I know. And Jamie, you're so right. Most of these are easier than it looks. And please eat those up. Pass them around. Go crazy. Cade bought them. Thank him. Okay. Questions? And Jamie, you are so right. Most of these, when you see the explanation, you go, oh, yeah, that's no problem. So we just need to review it a little bit. And our scores are going to go through the roof, Gracie. You watch. Hey, you're going to do great. Number 12. How are we doing on time? Am I boring you to death? Julia and Caleb out there in the interweb land. So we're going to, after we post this, we'll text them and say, go to Google Classroom. All right, number 12. Oh, hey, this is a good problem. And this one is neat because normally when we do U substitution, we don't change our limits of integration because most of the problems in high school calculus aren't that tough. You can just substitute back in. This time, they changed their limits of integration and gave the answer in that form. And I think that's what threw a lot of you. Using U equals square root of x, which is the true of the following. The function was the integral from 1 to 4 of e to the square root of x over square root of x dx. Yeah, people had questions. In fact, I think this had the loudest belly aches. Okay? Jamie, live in the moment, man. Come on, you can do it. So we let u equal I'm going to move this over. Let u equal the square root of x. Then du dx equals what? You may want to consider that as u to the 1/2. What does du dx equal? 1/2 x to the negative 1/2 equals 1 over 2 times the square root of x. Yeah? Yeah, okay. And we've done that one a fair amount. And so du equals 1 over 2 times the square root of x dx. Now, at this point, let's say change your limits of integration. So when x equals 4, well then u equals the square root of 4 equals 2. And when x equals 1, and again, I'm just taking my old limits of integration here. I'm saying when x equals 4, I'm plugging this into square root of x, my new u. When x equals 1, then u equals the square root of 1 equals 1. So now my new limits of integration are from 1 to 2. What? Craziness. And normally we don't even need to bother with that because you can just sub back in at the end and not change them. But that's fine. We can do that. It's not going to scare us. So now we have, I'm going to go a different color just to, yeah, not too much. We have a little bit in the homework, but not too much. You're right. So that's why we need to review it, and I'm glad we are. So we have now our new limits of integration, and we have e to the u, shoot, I gave it away. We have e to the square root of x. What's that going to be? E to the u, I'm thinking ahead. Now, another thing I want you to think about is we might want to express this. Maybe I'll move this down a little. We might want to express this as, move that down. Remember yesterday we were just saying let's make this all in one line. That moved on me at the last minute. Yeah, that's not good. Let's make this all one line and go times 1 over the square root of x. Okay? Because that's looking a whole lot like this over here. Right? Notice 1 over 2 times the square root of x, 1 over square root of x. So we're getting really close. We said u equals the square root of x. We're getting really close to e to the u times, no, and I lost a dx somewhere here. I'm going to put that in a box so it doesn't confuse us. Times, we're almost there. We've got 1 over 2 times the square root of x dx. All I got to do is write what over here? du is right. I just put du there, and I'm really close. I've got to make one little adjustment to make this look like this. What do I have to do? 2. Do what? Outside 2. Right. Because when I go 2 times du, I get 2 times this. Right, which is 1, which is beautiful. We're trying to get this anyway. So all I have to do is throw a 2 out here, and I've got e to the u du. Beautiful. yeah, all of a sudden this whole mess up here is really pretty easy to do. And so then that's all they're asking for. Look at the answers in number 12. You don't have to evaluate it. They're just saying set it up. Yeah, and that is C. Now, you could have done it the way we normally do and gone backwards and gotten the same answer, but this is a lot easier. So I'm glad we practiced that one. So it's C. Yeah, it's that one was a little tricky, but not horrible. Okay. Questions on 12. Okay, then we went to 24. Yeah. Okay. Why are you laughing? Calvin, we know you like to eat. You're not gonna. You don't even need to try to hide it. You're a munch hound. Baron von Munchhound. Right. Okay, number 24. G of x equals x squared times e to the kx. And here's another one where the k's freaked you out. K stands for constant. Okay. And then there's a word, critical. Okay, critical. Critical point. Yeah, it's a possibility. Critical points occur when? Good, K, G prime of x equals 0, or, and this is more rare, but, or where, what's the other possibility? No. And we all know this one, but we kind of forget about this one just because it doesn't happen as often, at least in our class. Where g of x is undefined, and you'll often see that as does not exist. Is another way to think about that. So that is a possibility too. But let's consider primarily where g prime of x equals 0. But we still don't want to forget the other part. So we have g prime of x is necessary then. What does that equal? Well, what's happening here? Need a product rule, exactly. So g prime of x then is equal to x squared times the product of the second, which is e to the kx chain rule, times what? Think easy. No. E to the kx chain rule says, what if this were 3? You'd know it easily. You'd say, well, it's e to the kx times 3. So it's just times k. Don't let that k freak you out. You remind me of Algebra 1 students with pi. They freak out. It's just a number, and so is k. It's just a number. So it's the first times the derivative of the second, then what? Plus 2x. I do it in the opposite order, Calvin, but you're right. It doesn't matter. Plus 2x, not squared. Plus 2x times e to the kx. Here's our product rule. Okay, now, critical points occur when g of x equals 0. So we can say 0 equals that. I'll probably write kx squared e to the kx just because it makes more sense in my brain, but you don't have to. And times, or plus 2x e to the kx. Okay? So, check it out, everybody. There's a couple of different ways we can proceed, and it comes out right either way. What do you want to do next? Go home and cry. They're not that bad. Well, and you don't have to do it this way, but I just always notice that that and that are in both terms. So you can factor it out. You don't have to. 0 equals e to the kx times kx squared plus 2x. Good. Okay. And, to me, that just makes sense. And so now we can say, well, g primed, normally when you do this, think about what we normally do when we take the first derivative and set it equal to 0. We solve it, but at that point, we already know what x is, right? So we can say g prime of 2/3 equals 0 equals e to the k times 2/3 times k times 2/3 squared plus 2 times 2/3. I need another parentheses. It's not that bad, guys. This will clean up, I promise. I promise. I really do. Well, because they said in the beginning, in the initial problem, they said at the point where x equals 2/3. And that's all we're doing. Okay? And they're saying, for what value of k will that, I guess graphically you would say, and I don't even know what that function looks like, and it doesn't matter. They're just saying, for what value of k is this a true statement? Meaning k is up here somewhere, right? And depending on what value of k you have, I should draw this separately. Depending on what value of k you have in there, this thing's gonna move up and down a little bit or over or whatever. It'll change. It'll be a transformation. But they're saying when x equals 2/3, what value of k will produce? I guess it would have changed. Maybe more like that. I don't know. For what value of k will that be a critical point where the slope is 0? That's why we set it equal to 0. Okay? Man, y'all are looking sleepy. Shapers of your life. I don't know. All right, so when you plug these in, and it's not that bad, you clean it up. I should go stick with blue, I guess. Plug it in. It's not horrible. You get oh, I know what I did. That was kind of sneaky. I did, I divided both sides. Shoot, that's even easier. Notice that this is something times something else equals 0. Well, what does that mean? Yeah, I can get rid of part of this. That's a little bit tricky. I can divide both sides by that. And then I always feel kind of guilty for doing that, but it works. I know. I feel like I'm cheating. Equals k times 4/9 plus 4/3, right? And then I can get negative 4/3 equals k times 4/9. And then what do I do? Thank you, Calvin. Again, you saved yourself. Multiply by the reciprocal, 9/4, right? Times negative 4/3. Don't lose your negative, equals k, and that's equal to, well, the 4s can divide out and become 1. And so that's 9 over negative 3 equals negative 3. Is that one of our choices? You sound disappointed. I know. All of these, I guess that was A. All of these are doable. So don't get down on yourselves. I know you can do these. All right. How much time do we have left? Not enough. Okay. Gosh, this one was just fast. I'm not going to. I got to do this really fast because we're running out of time. 79 was calculator yes section. But you didn't need it. This was weird. It was a calculator yes, but you totally didn't need it. The velocity of the particle at time t is given by v of t. All we got to talk about, okay, is you got to remember the formula for average value. That's it. Okay? Because just remember the relationship there and the formula for average value. And I'm just going to go really fast on that. Recall, review. If you didn't get this, VI, i.e., review this section, average value, and we'll look it up here in a minute, make sure you have it. Average value equals 1 over your limits of integration are what? 0 to 8, so 8 minus 0 times 0 to 8. I mean, it's the only thing you had to remember was this part right here. Now v of t dt. And you're done. That's all they want. Equals 1/8, 0 to 8, v of t dt. Why do they put that in the calculator section? You're done, and that's B. Where's average value? Someone look in your text, please, quickly, and I can't remember what section that was in. Average value theorem, yeah. Yeah. I mean, that one I think was so easy you probably wouldn't trust yourself if you came up with that. You'd say it can't be that easy. Average value theorem. 3.2. Okay, you guys just look through that briefly. That doesn't take a huge amount of your time. And then we went to, oh man, we're going to run out of time. We went to 84. And I guess maybe I should do this one online, and because we're going to run out of time. Go this weekend, because it's a Friday. Go this weekend to, write this down right on the front of your task. Ask Mr. Calculus, or just Mr. Calculus. I can't spell. Thank you. And it's the first one that comes up, and then we're looking for 2012. There are the answers of free response, but you have those on your packet, so you don't need those. But 2012 multiple choice practice exam answers and solutions. And these are right here, multiple choice answers and solution. And then if we want to do, what was the last one, 84? We go right here to 84, and they give you, kind of a quick one, a little quicker than maybe you want, but enough to get you going at least. So definitely do that on the remainder of those problems, because I know we're going to run out of time. And and check it out. Okay? What do you mean? What are the problems we did for the review? Oh, okay. Okay. I wonder, it won't let me do that. I wonder if I can do a split screen or something. I kind of want to show you the process. Aye, that makes me crazy. All right, let me minimize this, or not minimize, but make it a little bit smaller. You know, if you move to another country, you'll have an accent, and everybody will think you're cool. Jamie, that was pathetic. That wasn't even close. That was like the worst throw ever. Oh gosh. You know, my day isn't complete unless I make fun of Jamie. It really helps. Okay. So, but you know, you don't need to be a good throw to pole vault, right? You can go 15 feet and not hit the broadside of a barn. Okay. So, I don't know if I can do both of them, but I'm going to try, man. Don't try this at home. Never been done before. Oh man. So the ones we talked about reviewing, I'm sort of in the mode here, kind of. The ones we talked about reviewing last night, and I'm sorry I didn't get to all of these, are 88, 90, 92. And you might have done fine on these, some of you, but number 3 in the free response. And this one, the solution is in your packet. And number 6, part C, and I will talk about these on Monday if you don't get to them. But this weekend, definitely review these guys and check it out. Well, I probably will quit here. Maybe I can get 84 in. I don't know. Maybe not. But it's okay to go through this process. There's a mountain of stuff online. 84. Let's try to get it in real quickly. Okay, it says for the interval x greater than negative 1.5, less than 1.5, let f be a function whose first derivative, f prime of x, equals, man, that you love those e's, I know it, x to the fourth minus 2x squared plus 1 minus 2. Right away, this jumps out at me is because it's a polynomial. I know I can get the derivative of that pretty easily. There's no variable term on this one. Which of the following intervals is the graph of f concave down? Now, let's review concavity really quickly. What happens? What do we need something to happen for an interval to be concave down? No. Say it. Yeah, f double prime of x needs to be less than 0. Good, Gracie. Any interval where the second derivative is less than 0, we're golden. And it means it's concave down. Okay? So that's what we're looking for. Consequently, well, we're given the first derivative, rats. We can't get the second derivative, can we? Oh, we can. So, don't be scared. I forgot my equal sign. F double prime of x then would equal e to the something. Don't be scared. Just put it up there. No matter how long it is, just put it up there. Times, chain rule, the derivative of that something. And I'm going to do it in 2 steps, plus 1. Jamie, can I move these? Okay, thank you. And then um, minus the derivative of 2. Well, we know that's 0, but I just put it there so we don't forget, okay? And then where this is less than 0, comma, the original function or the parent function is concave down. Boom. I will be here after school if anyone wants to see me. Study hard this weekend, folks. We'll do a little bit more on Monday. Test is Tuesday morning.